you guys must put at the end of it .fas, which means at FASTA file format. If you guys
FAS.
put on another format, it
Okay.
will not and cannot be uploaded in the Mega software.
Dot
So
FAS.
this is
Okay.
important. So you guys save it. I will just take it anywhere. So that's all. So then this file will use when you use the Mega. So just open later on, then open the Mega. Okay, we will start our Mega now. So the first thing first is you guys need to align those sequences. Okay, you guys need to take note this, alright? So the first thing is you guys will choose the align part and choose the edit or build alignment. So let's wait a little bit. Okay, so the option must be retrieve a sequence from file, not under this one. So just click OK, and you guys need to search for what you guys. Where is mine? Okay, I save mine into my desktop as where is it? As this one. It
FAS.
will be this one. This type is FASTA file. Right? I save it as bamboo bat. So this one, you need to upload this one, what you saved just now, into the Mega. So okay, this is the outcome when you upload those sequence into the Mega. So after that, you guys need to select all of these sequences. Select, which means Control A. Select of the all of the sequence. So Control A, and later on pick alignment. Then choose also align by
My
cluster
cluster
W.
W.
So just click OK. Do not change anything. Okay. As you guys can see, it's already aligned. So the next step is you guys need to delete other things that are not that didn't have any base pair, any base like ATCG. There's nothing, right? So you need to delete this one. Make sure until it's all in. So delete, just click the button delete on your laptop keyboard. So it will be deleted. And also at the end of the sequences, same one, you need to delete it. So again, delete on your with your button delete on your keyboard, just like that. So after this, we will
Sure.
yeah, yeah,
Slow down.
slow down. Okay.
Yeah.
Kalau if you guys need me to slow down, let me know. Not understand anything, let
Excuse
me
me.
know. Yeah.
Uh, about the best pay. If
Yeah.
there's only like one is missing, so you have to remove all of it.
Yeah.
Okay, thank you. Proceed.
Okay. Just now, okay. After that, after you this already aligned, so after you align this, you will export all this data into Mega format. So how to do this is you pick data and choose export alignment. So choose Mega formats and save it again. But right now, it will be on Mega file. So just put bamboo that's Mega. I just put like that. So and then save it. Save it again. I save from my desktop. Save. So the input title of the data, you need to put the gene, which is cytochrome or cytochrome oxidase 1, CO1. So for my group is site B. So I will just put the site B. So okay. Protein coding nucleotide sequence data. So just pick yes. And it's all done. You have saved it. So put down the window. Okay. Anything you want to ask before I proceed the next step?
No, miss.
Alright, I will proceed. I will proceed with the next step. So the next step, you will input all the data that you have saved in mega format into this mega software. So the next step is you will choose the data button, and you will choose open a file session. Okay, you need to choose the file that you save as mega format. So in my case is this one. So BabyBats Mega. This is in mega format. So this is the one that you choose and open it. Okay. So I already upload all my data just now into this mega ni. So okay, this is the important thing. You need to do this, select the genetic code table. So for you guys, I think you guys all do mammals, right? Because all I see in the list is Microchiroptera, Urinae, and all of those are mammal. So you guys need to put the to select the genetic code table. The genetic code table you guys must put as vertebrate mitochondrial, not another thing. So if you guys do insect, maybe you guys can choose invertebrate mitochondrial. So for us right now, we will choose vertebrate mitochondrial. This is so important. Make sure you guys change it before doing anything. Okay. So just click OK, and that's all like that. So okay. So after that, we will do the what we call a grouping which, okay, for you guys, for my data just now, I have three species, which is Thalanotris pachypus, Thalanotris robustula, and also Dystropus stylopus. Okay, and also one outgroup, right? So I have four groups. So I want to group them so that later on my result, I can see which one is which one, which group in which group, like that. So what you need to do is pick the data again, and also pick the select taxa and group. So choose this, and this window will pop up. Okay, for this one, it is easy. So you guys need to just pick the new button and just name what species that you want to group. Which mine is for Thalanotris pachypus, Thalanotris robustula, Dystropus stylopus, and also our group. So there is four groups. So I just put it like this. So and I add another one. Dystropus. And also the outgroup. Outgroup you guys need to do also. Okay, that's all. So to group them, you need to pick like Thalanotris pachypus, you pick that one, and then you pick which one is Thalanotris pachypus in your sequence in here. So like this, and you guys just click this button, okay, like that. So click this one again and get it into the group, the pachypus and pachypus. Okay, the next group is robustula. So you guys need to choose this robustula and later on click this until all robustula go into that group. The same one is for Grisropus. Click this. And the last one is for Pipistrella javanicus, which is a outgroup. Cool. So you guys already grouped them into their species. So we will save it. Just put OK. Click OK. Just click OK. Click OK. Okay. Click OK. So you already group. Later on, when we do the phylogeny, we'll know why we need to do that. So the next step is we need to choose the model for our analysis. So we need to find the best DNA or protein model. So this one, all our analysis, when we do that analysis, there's a box which is we need to choose what model that we need to use for each one that we will done later on. So this one, this particular step will show us what do we need to find, what do we need to choose later on. So just click find best DNA or protein models and just click yes. So this one you do not change anything and just click OK. Okay, so it will form into this table. So all of this is list of the model. So whenever you do another analysis, they will need to use model. So this HKY plus I, HKY plus G, HKY plus G plus I, and anything. So what model that you need to choose is the most upper part, which is you guys need to use the HKY plus I. But if there is no um, option for the first one, you guys can choose the other one. So if there's no option on the second one, then you guys need to choose the third one. If you also so the fourth one like that. So later on, I will show you which one that we will choose. So just save that table. Result, just click it, and later on, okay, this one we will let after this we will do the genetic distance between them. So but I think it's okay. We will do the phylogeny first. So the phylogeny is the three phylogeny. You guys need to do three phylogeny tree, which is maximum likelihood, maximum parsimony, and also neighbor joining. For just to show you guys, I will do only neighbor joining. So later on your analysis, you will also do another thing. So I will just show you the neighbor joining because the neighbor joining is the um, easiest and less time taking because maximum likelihood and also maximum parsimony will take some time to do it. So we'll just choose this one. So I will choose construct or test neighbor joining tree and just click yes. Okay, this one. Okay. The test of phylogeny, you guys need to choose bootstrap method.
Yes.
Make sure you guys change this. And the number of bootstrap or
Yes,
replication
1,000.
must be 1000.
Yes.
Okay, this one is nucleotide. Okay, this one is the model. Just now you we already done how to find the best protein, the best model, the best protein and DNA model, right? So this step we need to choose that model, which model. So in my case right now, the first one is HKY plus I. HKY is Hasegawa Kishinoyano plus I. So I need to choose Hasegawa Kishinoyano. However, in this option, there is no Hasegawa Kishinoyano. So I will choose cancel first and look at the table again. After Hasegawa Kishinoyano option, what do I have? The second one is Hasegawa Kishinoyano again. The third one is also HKY again. And the fourth one is TN93 plus G. So how do I know TN93 HKY is what? At the bottom of the table, they also give you all the abbreviation. So HKY is Hasegawa Kishinoyano. So the first one that we will choose is TN93. TN93 is TN93 is Tamurane. Okay, is Tamurane. So we will find Tamurane plus G. We will find Tamurane. Okay, we will find Tamurane. So there is Tamurane model. So we will choose this one. Okay, so choose Tamurane and plus G is this one, gamma distributed. This one you need to choose based on that table also. Plus G plus I or there's not no plus. Or if plus G you need to put gamma distributed this G. If there is no plus anything, just uniform break. If have plus I, there's another option, G plus I. But this one does not, so we will just put gamma distributed. And pairwise distribution. Okay, that's all. And click OK. So this is the result of the tree that you will get the output of it. So, okay, in this case, our outgroup is already inside the tree. So what we need to do, our outgroup must be outside of the tree. So just click the branch of the outgroup like this and choose this one, root the tree on the selected branch. So click it. Uh, that will make all the outgroup to be the outside of the tree that we have been doing. So in this case only, if you guys have already, if your tree is already good, outgroup already outside, so it's okay. But my case, the outgroup is inside, so I need to do that. If you have this problem, you guys can also do that lah. So okay, um, just now I already teach you how to group them, right? So this is the reason why we need to group them. If you guys can see, there is like labeling of the tree, like Tyrannosaurus passipus, Tyrannosaurus robustula, Eustrapus, and so our group. So this one is this is the reason why we do all the grouping just now, so that we can see which branch is which species, is which group, and we can see that that branch separating other branch with that species is separated with other species, and there is no problem with it like that. So this is the one of the result that you guys need to have later on. So okay, so we got the tree. So later on, you guys need also to do another two, which is maximum likelihood and also maximum parsimony. But I won't show you guys because it's just the same like neighbor joining, but maybe their tree will look exact, maybe exactly the same or slightly different. Okay, so for the tree, okay, for the tree, there is value outside of the branch, right? Like 100, 97, 97, 97, and 100. Okay, this value is what we call bootstrap value. We choose 1000 times of bootstrap value just now before we do this tree, right? So this is the value, the outcome of that value, which means 100 is, which means 100% that this branch we will be cladded together, will be together. Just same like this, 97, that 97% that this branch will be cladded together or separated like that, macam tu. So this is we can say that this one will will menentukan the confidence level of the branch of the tree like that. So okay, the next step after you guys do the tree, you need to do the genetic distance, which is you need to know how much is this how much are the distance between those species, or between those group. Later on, I will tell you what is mean by genetic distance. So the first step to do genetic distance is pick the distance tab, and then we will compute. We will choose compute pairwise distances. Okay, for compute pairwise distances, they will compare genetic distance between each species that you have. Okay, so we will do it first, compute it, and yes. This one, okay. For genetic distance, we will ignore the best DNA and protein model that we have used, but we need just use Kimura 2 parameter model. This is the only model that we will use if you do genetic distance. Okay, so the gamma distributed also you need to choose it as uniform rate. You don't need to change, so click OK. Okay, so the output will be this. Okay, for this genetic distance, pairwise distance, there will uh, compare the distance between each species, which means, okay, the number one is Talonictris pachypus from Bongo Range, and the number two is Talonictris pachypus from Silabo Cave. So, how do you want to find how many the genetic distance between them? So, how do you need to macam mana nak baca this diagram is that set the one and number two. So this is the difference between number one and number two. Number one and number two. So this nilai is 0.009. We need to change it into percentage. So if you want to change it into percentage, you will multiply it by 100%. So if you will multiply it with 100% onto, so that's mean 0.0, it will be 0.9%. Okay, this this is the thing that you need to take note. If more than 5% of genetic distance, there will be assumed as different species. If they are less than that, they might be the same species, which means their genetic distance are so low, and or lower like 2 to 3%, they might be sister species or subspecies like that. Okay, for this case, this number one and number two is the same species, right? So that is the reason why the genetic distance is so low, that at 0.9%. So if you guys want to see another example, okay, for different species, okay, number one is Tylonectris pachypus and number six is Tylonectris robustula. So I choose number one and go to number six, number one, and go to number six is this one. So if if we multiply it by 100 to get the percentage, it will be 16.2%, which is the genetic distance is very high and more than 5%. That means there are different species. So this genetic distance will help you to determine whether these species are the same species or there are different species or subspecies. For this case, there are different species because there are more than 5% and the genetic distance is really high, 16.2. Unlike the Pachypus, number one and number two, Pachypus and Pachypus, which is the same species, only 0.9%. You guys can see that. Also the same like Tyrannosaurus robustula, number 6, and Dystropus number 10. Okay, 0.18, so convert to percentage is 18.2. So there are different species. So this is how you guys read this table. Okay, so okay, this one is we do the genetic distance, comparing the genetic distance between each species. So how do we do comparing genetic distance between each group of the species, which mean Tylolectrus pachypus and Tylolectrus robustula in group, what are their genetic distance? Berapa jauh dia punya genetic distance, like that. So how to do that? That's why we do all those grouping. So we choose the same thing, distance, but this time we choose compute between group mean distance, which mean we will compare genetic distance between the group yang we already group just now. So compute between group mean distance, select yes, and that's the same like the other one. Bootstrap 1000, Kimura 2 parameter, uniform rate, and click OK. So you will have this table. Unlike those, there will be only um, four option, which is four group, which is talian cepat-cepat, robusta, and also outgroup. So this table, they will show you the genetic distance between those groups. So you guys can see it as a whole thing, okay? So the first one is, just to let you know, so the first one is Tyrannosaurus pachypus. So how to, okay, the genetic distance between T. pachypus and T. robustula is 16.7%. So it's high because they are different species. So the same for T. robustula and G. tylopus is 18.7. So the same for Tyrannosaurus pachypus, number one, and also number three, which is G. tylopus, 21.5% genetic descent. So we can see that value in here. Okay. So anyone want to ask anything? Do you understand? I will just assume you guys understand. So,
Understand.
Yes, yes.
hmm, okay. So I want to highlight the important thing, is the result that you must have and that we will use on your assignment, I think. So you need to have this philo 3 in your results. Okay, the first one. And you guys need this genetic distance table on your results. And you will need to recreate this table. Later on, I will show you how to recreate this lah. This result, only these two on your results. No need and nothing else. I think you don't need. But the three will be maximum likelihood, maximum parsimony, and also neighbor joining. Three, and this table. Okay. So the result. Wait. I will show you first. Human. Okay, we will put those results of genetic distance in this form. You need to directly convert them into percentages, and also you guys don't need to put the upper part of this result. You guys just need this lower part only. Okay, and this one, also this one, the lower part only. The upper part you guys can just ignore it. This will be used. Okay, and also the value must be in percentage. So I think that's all for Mega. Yeah, that's all Mega do at your stage that you need to do in your assignment. So Do you have any question? Do you guys have any question? Just and make sure you save your mega file later on. After you're done with this and everything, you need to save it. Um, what? You need to save. Wait. Okay, the three. How to save it is you just take the image one. You guys can choose BMP, PNG, anything. So usually I just choose PNG to save my image of these three because after you close the mega, you won't have these three in that mega anymore. So you need to save it earlier, just in case. Okay, or else you need to do the three again. It's okay for NJ, it will take less time, but for MP and also ML, maximum likelihood, it will take such a long time. So if you didn't save it earlier, then you need to do it again and it will take a long time. Especially if you have more sequence. More sequence, more time, like that. Okay? I think that's all. So if you this is I think okay. Okay, I think that's all for Mega. Do you guys have any question right now?
No, miss. I
Question?
don't
Do
have
you have
any
any
question.
question? So if you have any question later on when you do the Mega and my group, you can just ask me. And if you don't understand, the other group you can ask Kak Emirita and anything I will update you later on. So if you guys have any problem, just WhatsApp in the group and I will help whatever I can. Okay. So I think that's all for today. Yep. And just like that. So Kak Amy nak cakap apa-apa?
Ah, tak ada.
Group saya ada international.
Ah?
Group saya ada international sebab itulah saya kena
Oh,
speaking.
itu. Okay. Now, so far, okay. Thank you. Thank you, Shu.
Okay, thank you, miss, for the explanation.
Thank you, Miss.
Thank you.
Thank you, Miss.